Trigonometry is the study of things with three angles, so triangles. We'll break this into two parts. So first let's just do some thinking about triangles. And you will recall that one good thing to know is that no matter what size the angles are in a triangle, they always add up to 180. And if it happens that one of those angles is 90, well, the angles still add up to 180, but if one is 90, then the other two must add up to the other 90, so that's handy. And the kind of trig that we're going to do is focused on just right triangles, 90-degree triangles. What do you do if you don't have a right triangle? Well, one thing designers often do is they break triangles into multiple triangles to make right triangles. So here's this structure. The legs are at 45 degrees, and we know the height. We don't know the width. So what can we do to find that width, x? Well, we can make two right triangles. Just run a vertical line down here, and that splits the thing into half. Now, if these two distances are 5 feet each, we know that the overall height must be 10, don't we? And here is a 45-degree triangle where one side is 10. And if that's a 45-degree triangle, what do you know about the other angle and the other side? You know they're the same. So you know that bottom side must be 10 also. All right, there's our 45-degree triangle on this side. There's another one just like it on the other side. So each of those half lengths is 10 feet long, and that means the overall length must be 20. And we did that just by really simply sketching a couple of triangles and thinking our way through it. Here's another one. Ooh, some oddball numbers. You're trying to find the length of the base of this triangle, and it's not a right triangle. What do you do? Well, once again, you can split this thing into two triangles. You can run a vertical line from the top down perpendicular to the base there. Okay, now you got two triangles, 90-degree triangles. And this one on the right is a 45-degree triangle. Now, if you already know that the height is 5, what do you know about the other length? You know it must be 5 also, don't you? All right, so that takes care of part of this width. Now for this other skinny triangle, you know that it's 2 units across up here at the top. It must be 2 units across at the bottom too. So you've got 5 on one side, 2 on the other side. You must have a total width of 7. So again, we did that just by sketching and thinking. Let's conclude by thinking about our useful tool, the Pythagorean theorem. A squared plus b squared equals c squared. A squared and b squared are the two sides of a right triangle, and c is the hypotenuse of the right triangle. So for example, here's a triangle, right triangle, where one side is 3 inches long, another side is 4 inches long. We're trying to find out how long the hypotenuse is. If we know a squared plus b squared equals c squared, we can square each of these. 3 squared plus 4 squared is going to equal c squared. Okay, what is 3 squared? It's 9. What is 4 squared? It's 16. Okay, so there's our a squared and b squared. And those two are going to equal c squared. All right, so 9 is 3 squared. 16 is 4 squared. So a squared plus b squared is 9 plus 16. Those add up to 25. Okay, so c squared is 25. How do we find c? If we know c squared is 25, how do we find c? Well, if we do the same thing to both sides are still equal. In this case, if we're trying to find c, we could take the square root of both sides, or the square root of each side. Doing the same thing to both sides means those sides are still equal. What's the square root of 25? 5. What's the square root of c squared? C. So c is 5. And by the way, this gives us a classic triangle. It's called a Pythagorean triple. You might be familiar with those. So this is a classic 3, 4, 5 triangle. A Pythagorean triple is a triangle where it's a right triangle where all three sides are whole numbers. There are just a few of them. 3, 4, 5 is a common one. 5, 12, 13 is another common one. And you'll notice that our book's author likes to throw these in there quite often. So this takes us to trig formulas, and in your math class, I'm sure you ran into SO, CA, TOA, a memory trick to help you remember that SO, sine, equals opposite over hypotenuse. Why that's so is we're taking the first letter of each word. So S equals O over H. So CA, C equals A over H, or cosine is adjacent over hypotenuse. And TOA is T equals O over A, or tangent equals opposite over adjacent. In the next set of slides, we are going to go over these a little bit more and try and get a handle on just feeling comfortable with them and feeling comfortable with what the heck are these anyway. But for now, go to the short quiz. I think it's just got 2 questions. Go answer those 2 questions, and I'll meet you on the other side to do the next video.